Welcome back to our MicroPython video tutorial series. This is part 2 of the series. In part 1, you saw how to flash the MicroPython firmware onto an ESP32 microcontroller. And in this one, we will see how we can configure our VS Code installation to work with MicroPython. Now, before we get started for today, I need to address a few issues that you might have encountered. If you haven't used your microcontroller before on your Windows machines, then you probably have missing drivers for the USB to serial chip that is there on your microcontroller. Usually there are two common variants. One is CP2102, the other is CH341 variant. If you look very carefully what USB to serial chip you have on your microcontroller, and if that is a CP2102 variant, you need to go to the Silicon Labs website and download the uh, corresponding Windows driver for that and install it. In this case, this driver or this one will work perfectly. Or if you have CH9102, you would actually need this driver, CH341 driver. And if you go to the corresponding website here, this chip is made by WCH. If you go to this one and if you download the corresponding Windows driver and install it, the device will be detected on your Windows computer. And if you have used your microcontroller earlier, if you were able to program using Arduino IDE, then you definitely have the drivers installed. So this won't be an issue for you. With that being said, let's get to today's tutorial here. Previously, we installed in our Python distribution, we installed mpremote and the MicroPython stubs, and also we installed a static linter. We installed pylans for that purpose. And today we're going to proceed from there. Now, if you don't know what port your device is connected at, you can use a mpremote command to find that out. And this command is mpremote devs. So if you say mpremote devs, it will actually list out all the ports that mpremote can see, and out of these, one will be definitely the device that you are looking for. Ideally, mpremote automatically detects the port when you are connecting to the microcontroller. If it does not, then that might come in handy. All right. So let's run the mpremote command, and yes, it has successfully detected the corresponding port, and I'm connected to the microcontroller. Now this is an interactive Python shell, Python REPL, in fact. So here we could write our Python code and things would work perfectly. And this is good enough for writing or testing very small snippets of code. But if you're doing any serious programming, you would need to have a proper IDE set up for that purpose. So now we have opened VS Code into the folder where we previously had downloaded the MicroPython Flash. And we are going to actually create two files to run on our microcontroller. One of these files would be boot.py and the other one would be main.py. Now, if you are familiar with Arduino IDE, then you would be familiar with something like this. You have seen the setup function and the main function. So these programs are very similar to those. The boot.py is very similar to the setup function on your Arduino programs, and the main.py is similar to the loop function. But except understand that the main.py does not run repeatedly. So first, the whatever you set up on boot.py would run, and then main.py would actually run. So usually we put up all the configurations, etc., on boot.py. Speaking of configurations, boot.py usually have all the imports that you need to have. Now, if you go to the MicroPython documentation, you would see that like there are, again, I need to choose the correct version here. Yeah. So if I go to the MicroPython libraries, you would see that a large number of Python standard libraries are actually implemented, or microfied implementation is there inside MicroPython. But then there are MicroPython specific libraries. And in order for these to be detected correctly in our standard Python distribution, we had to install the MicroPython stubs. So if we have done all that correctly, we are good to go here. So one of the things that you need to import is the network library. Of course, you are using an ESP32. And if you are using an ESP32, then you probably are doing so for its networking capabilities. So we are going to import the network library. And with that, we are going to actually connect to our Wi-Fi. Now, there are two ways in which you can configure the Wi-Fi hardware on your ESP32. You can either put it on station mode so that it can connect to your pre-existing Wi-Fi networks, or you can configure it in AP mode, so access point mode, where it will be its own access point, so other devices can connect to it. So we will be actually configuring the station mode today. Let's create a variable, uh, and so this is not correct. Sometimes this is also incorrect. Yeah. Sometimes the copilot might give you incorrect results. Like copilot was once again trained on older data. Now this is the correct way of configuring the uh, station object. Now we have an object named sta, and that's a wireless LAN object. And what we can do, we can check whether or not this station object is active. We can call this method, call the active method on this. Now usually when you are configuring the network within the MicroPython REPL, you would actually check these things like this. These methods have two ways in which you can call them. You can either call these methods without any input parameters, or you can pass on some input parameters. In this case, you can pass on a true or a false. So if you don't pass on any input parameter, it will just show you whether or not this interface is active. It will just return a result accordingly. Or if you pass on an input parameter, in this case true or false, it will uh, either activate or deactivate the network. All right. Then if you're on a MicroPython REPL, you can also try to scan the corresponding network here. So let me scan for the available networks. All right. So let's say this is my code so far. One thing to note before we proceed, we need to make sure that we have chosen the correct Python distribution. So if you have multiple Python installations on your computer, make sure that you choose the correct one. So I installed mpremote and everything else on the base Anaconda distribution. So I'm choosing that one, right? So this is fine now. So now in order to run this into our microcontroller, I need to open our terminal, and let's say I have to say mpremote run boot, and say it is saying mpremote no device found. And that is not happening because I don't have anything connected, but rather this is happening because I have mpremote connecting to the microcontroller. Here in the terminal, I have mpremote connecting into the microcontroller. I have to close that connection first, and then this will work. And so what is happening is that this program, so what is happening is that this program was copied over into the microcontroller through the serial port, and then it was run into the microcontroller, but this was not actually saved onto the flash memory. So while you are actually developing, you this is a command that you need to run. You should not wear out the flash of the microcontroller by repeatedly copying and pasting it into the microcontroller, but I will show you how to copy and paste, obviously. But thing is, you don't need to flash it every time you want to run the program. You can just remotely run the program like this. Right. So what is going to happen through the serial port? It is going to remotely copy it into the RAM and then execute it there. So it will not be wearing out the flash in the microcontroller. But let's say we did a scan here, but we did not print anything. Let's print the result of the scan. So it will scan the local whatever Wi-Fi devices it gets to see. The result came up from the microcontroller, and it tells me that these are the Wi-Fi access points that are available near to it. And so this is my own Wi-Fi access point, so I'm going to connect to it. So this is the SSID of the access point to which I'm going to connect to. And there are some helpful information as well. So this 13 is the channel number at which this hotspot is operating at, and this is the signal strength, right? and false means it is not connected to this. On this program, once we have actually scanned this and we have seen that this actually works, we don't have to worry about this too much. So we are connecting, and we are connecting to our SSID, and in this case, SSID is correspondingly the password is, don't worry, this is just a demo password I created for this tutorial. Then there is a method called isConnected. And this isConnected method tells you whether or not the device is actually connected to the network. So if the device was successful in getting connected to the network, then this will become true. So we can use that inside a while loop. So if the device is not connected, then we might want to actually waste some time on that, right? So if this is not connected, we might want to waste some time. So what we can do, we can say we can retry for a while, right? So let's create a variable retry count, and say retry count is 0, and we are going to increment the retry count. And if the retry count becomes 10, then we're going to stop trying to connect to the network, basically, right? And retry count is less than say 10, we are going to, while the retry count is less than 10, we are going to try connecting. And every time we are trying, we have to wait for a few milliseconds. So from that, again, we are going to now import the time library, and then we are going to wait for like 500 milliseconds. Right. So now again, sleep is a standard Python function inside the time library, but sleep ms is not. Sleep ms is a specific MicroPython implementation. Stands for sleep for 500 milliseconds. So we're going to wait for 500 milliseconds and try 10 number of times. And obviously, if it is connected, then it will automatically break out from that, right? All right. So with that being said, this will try 10 times to connect it, and if it is connected, then it will say, okay, successfully connected, right? Let me print those as well. If it is connected, and then there is another method called ifconfig, and this ifconfig will actually tell you the IP address. So let's try it there. So let's run this. Again, we are running through mpremote, and as you can see, it was not able to connect. Okay, so the password was wrong. It was demo password. Yeah. All right. So let's try that. So it is telling me that there is an internal state error. So I might need to actually reset the microcontroller and start it again. Now, after 6 attempts, it was able to connect to the hotspot, and then it got assigned an IP address. This one, right? So my MicroPython device has successfully been able to connect to the Wi-Fi. With that being said, there is another thing that we can do uh, to access this microcontroller. So there is something called the webrepl. So far what we have been doing, we have been connecting the microcontroller through our USB port into the computer, and we are programming it that way. We can use also the webrepl to write programs over the internet. Let me show you that. So let me connect to the microcontroller through mpremote. Right. So once we have connected to the microcontroller through mpremote, let me now configure the webrepl. And it says, do you like to enable the webrepl? Yes, I'm going to enable the webrepl. And it is asking me to set a password. Okay, so I'm going to create a very simple password, 1 2 3 4. Yeah, that's fine. Okay. 1 2 3 4. All right. And do you want the changes to be activated on Reboot, yes. Device was rebooted, right? So let me exit out of that, right? And let me on this import webrepl. So I had to do the webrepl setup once, okay, through the interactive terminal there. And then now what we can do, we can start the webrepl server. Um, Okay, so Wi-Fi was connected and the webrepl server is at that particular port. So let me open this. And as you can see, we have a WebSocket connection to our device through the network. So, and I can click on connect and it will ask for the password that we just created, and the webrepl is connected. Now here, from this one, we can actually do our MicroPython programming very easily. And we can send our boot.py, main.py from here as well by choosing a file from here. And there is another thing I need to show you is that this is basically a replica of our REPL here. So if we have a REPL through the USB port, this is exactly the same thing. How can I show you? I can say print hello world, and that exact same thing will be appearing here. As a matter of fact, let me put them side by side so that you can see. If I'm writing something here, let's say import mesh. You see that? Import machine. So I'm importing the machine library. The same thing is writing up here. Okay. But this webrepl server is very convenient, but at the same time, it's very slow. So I don't like it. If I have the ability of connecting an USB port to the microcontroller, then I choose that path. But if you want to program your microcontroller wirelessly like this, then you are good to go and you can use a webrepl. Right now, I'm just disconnecting this for the moment. I will be connecting it back later. All right, so we remove the webrepl connection. So webrepl server will be starting, but we won't be using that for the moment. But so far, what we have done, we have uh, connected to our Wi-Fi network and we have started the webrepl server. But so far, we have been running this program, copying it over through the serial port. But what if I want to write it onto the microcontroller so that even if I reset the microcontroller, this will work perfectly. How do I do that? I do that through mpremote. So I can do mpremote fs cp. The FS stands for file system. We can just do CP because that is a shortcut there. So I'm copying this file, copying boot.py that is there locally on my device, on my computer here, and I can copy it into the boot.py on the microcontroller. So notice very carefully this colon symbol here. So this will tell me which file I am writing it on into the microcontroller. So there will be a boot.py file in the microcontroller. So I'm just copying whatever I have written here into the boot.py file there. So that copy was successful. And in the mpremote, if I say mpremote ls, it will tell me that there are two files in the microcontroller now. So there is this boot.py file and there is this webrepl configuration file. And you might want to guess what is there in the webrepl configuration file. We just configured the webrepl moments ago, and we just stored our password, right? So let me just check what is there. So how do I do that? Mpremote cat, sorry, mpremote cat, and the name of the file. So that is all there is in that that webrepl configuration file. And if I want to check what is there in the boot.py file, I will just say boot dot. All right. So you can see whatever we wrote, whatever we copied. Now we can uh, just reset the microcontroller, and this will again automatically work. So now we have successfully reset the microcontroller. Now once we have reset it, it has now connected to the Wi-Fi. And how do I know that? If I go to the webrepl once again and now I have the webrepl activated there. So I can just hit on my password 1234, and it actually connects me to this. Right. So another way in which you can actually program without using the USB cable, once you have the webrepl configured, you can send a file. And what file can you send? You can either send a boot.py or a main.py or any other file. This will be copied into the file system, and then this will actually, so let's say we are just sending the main.py, and let's say we are sending it to the device. We haven't written anything to the main.py file, but now let me go back to the mpremote, and if I do mpremote ls, it will now tell me that yes, I have another file, that is main.py, on the device. That's it for today. In the next one, we will see how we can configure the gpios. We will write our main program there and upload it through webrepl. Thank you for watching. I will see you in the next one.